Good morning, everyone. Welcome to Talk Tech with Turtle. My name is Robert Benkov. I'm an automation specialist with Turtle. I want to thank you for taking the time out of your busy schedule to join us today. Talk Tech with Turtle has become a great way for us to share technical information with our customers. I had the privilege of starting the series with my coworker, Casey Klawicki, several years ago. And since then, many of my coworkers have done an outstanding job presenting on a variety of automation topics. Today, it's my turn to jump back in. For those of you who have attended earlier or more recent sessions, welcome back. If this is your first Talk Tech with Turtle, thank you for joining us. If you enjoyed today's presentation, I encourage you to search Talk Tech with Turtle on YouTube. You'll find a growing library of technical presentations covering a wide range of automation topics. And if today's subject matter is not your favorite, don't worry, there's plenty of others that might be. Well, a little bit more about me. I've spent more than 35 years in the automation industry, designing systems, commissioning machinery, troubleshooting equipment, and helping customers solve real-world automation challenges. Today's topic is on the newest member of the ControlLogix family, the 1756 L9 ControlLogix 5590 series. We'll talk about specifications, but more importantly, we'll discuss why Rockwell developed this platform and what problems it solves and where it fits into today's automation systems. Please use the chat throughout. I'll review them at the end of the presentation and do my best to answer any questions during the Q&A. So with that, as they say, let's press the start button and get this thing running. Before we jump into the technology, let me give you a quick roadmap of where we are headed. We will start with the Rockwell, with why Rockwell felt it was time for a new generation of ControlLogix. From there, we'll look at the L9 hardware and what has changed. We'll spend most of our time on the features that matter in real applications, not just the specifications, but what they actually mean to engineers and end users like you. We'll cover cybersecurity, migration, and where the L9 fits. And we'll leave some time at the end, as I said, for questions. So feel free to enter your questions into the chat. As I said, I'll check them at the end. I know some of you probably thinking, just show me the new controller. Well, I physically don't have one in my hands. We'll get there, I promise, but it helps to understand why Rockwell built it before we look at what they built. Let's begin with a simple question. Why did Rockwell develop the L9 in the first place? So let's start with what I think the most important question of the meeting is. Why did Rockwell decide it was time for another generation of ControlLogix? The L8 controllers have been very successful. Many of you are running L6s, L7s, or even L8s today without any issues. So why introduce something new? The answer comes down to how industrial automation has changed over the last several years. Today's machines are expected to do much more than they did 5 or 10 years ago. We're connecting more devices than ever before. We're collecting more data. Robotics keeps growing. Motion systems are becoming more sophisticated. Vision systems are becoming standard instead of optional. Cybersecurity has gone from being an IT concern to something control engineers must think about every day. The expectations on the controller have changed dramatically. It is no longer just about executing ladder code. Today's controllers have to communicate, protect itself, exchange data securely, coordinate its motion, and still run the applications reliably. This is the real story behind the L9. Rockwell did not build it because they wanted a faster processor. They built it because automation itself has evolved. So basically, I'd like to ask how many of you have added robots, maybe vision systems, or significantly more Ethernet devices to your machine over the last few years? Seems to be a very common thing. Now that we've talked about the why, let's look at how ControlLogix platform evolved to get us here. Before we dive into the L9, let's take a minute to look how the ControlLogix has evolved. One reason the platform has been so successful is that Rockwell keeps building on it rather than starting over every few years. Many of you probably worked with one or several of these generations. On the screen, you could see the whole lineage, the original L1, pretty much when I started with Mid-Island and Turtle back in 1998, when the L5550 and the 556 and the 557 around 2010, and the 5580 around 2018, and now finally the 5590. Here we are in coming out this year. Basically, I want to throw out to you, maybe some of you can put in the chat what the oldest ControlLogix processor you have. Maybe you have an L5, an L6, or an L7. Maybe you're already using an L8. Each generation reflected what customers needed at the point in time: more memory, better communications, faster processing, better motion, improved security, and greater integration. The 5590 continues that evolution. It's not a completely different way of programming. It is still a ControlLogix platform that we know and love. What has changed is the capability behind the platform. One thing I want to stress is that Rockwell keeps the form, fit, function, compatibility across all models. They build on what they already know instead of asking us to throw everything away. So let's finally put our hands virtually on the hardware. So let's meet the star of today's presentation, the ControlLogix 5590, or as most of us will call it, the L9. At first glance, it still looks like a ControlLogix controller, and that's intentional. Rockwell wanted to keep building on the platforms engineers already know and trust. But while it looks familiar on the outside, quite a bit has changed under the hood. It was designed for larger applications, more connected devices, more motion, and today's cybersecurity requirements, all while staying in the same Studio 5000 environment that we already know and are familiar with. Let me take you on a quick tour of what we're looking at. On top is the catalog number. It's now laser engraved. That is actually an anti-counterfeiting measure. The access door lifts vertically for tool-free access. That door actually has a little hinge on it, and it stays in the up position, allowing for access to what's behind that door. There's a QR code. You can scan that code for product registration, receive manuals, find out information on firmware, if there's any security advisories, or even chat with tech support by simply scanning that QR code with your phone. Down the front, you'll find a USB-C port. Yes, that's the same connector as most of us use for our phones. For firmware, you can use it for programming, upload and download, and online edits. There's also a removable SD card. I believe it comes with the SD card, 8 megabytes for those who are interested, or we're going to pose that as a question. There's also a 3-position toggle switch that's familiar throughout the Compact and ControlLogix line. And at the bottom, you'll notice that there's not one, but 2 Ethernet IP ports. When I first looked at the L9, my first question was not how much faster is it? It was, where would I actually use it? That's the question we're hopefully going to answer today. So let's talk about what this all adds up to. Here's the thing about the L9. The value is not in any single headline number. It's the combination, performance, safety, security, and connectivity all working together. Rockwell did not develop it because there was something wrong with the 5580 series. They developed it because the demand of today's controllers keeps growing. Think about everything we ask a controller to do at once: coordinated motion, talk to hundreds of Ethernet IP devices, collect and share data, meet modern cybersecurity requirements, and handle integrated safety all at the same time. On the screen, you can see how it breaks down. The performance to run bigger applications, up to 80 megabytes user memory. Safety and security built in, and connectivity designed for a connected plant, and we will walk you through each of these steps. So let's start with the question a lot of you are already asking. What does it take to move to the L9? One question I get often asked is, if I move to the L9, do I have to redesign my whole control system? The good news is, generally, no, you don't. The L9 supports the same 1756 I/O as the 5580, so a lot of your existing infrastructure carries forward. But, and this matters, it's still an engineering project, not a drop-in swap. A good migration follows 3 steps: assess the application, validate the details, and execute the cutover deliberately. Things worth checking early is your Studio 5000 version, the controller firmware, the network topology, and your safety application needs. Obviously, your testing and commissioning timeframe. So I ask to the customers out there, who has a migration sitting on the roadmap because their planning feels bigger than the hardware? And here's the reason that the planning conversion is timely right now. This is a slide that I think is generally important, especially if you're specifying anything new. This is Rockwell's life cycle chart, and they do this for most of their automation products. The 5590 is the newest. You pick it for the longest availability. The 5580 is fully active, no plan changes. But look at the 5570, the L7. It's now listed as active mature, and it's not recommended for new installations. It's not security certified, and its final version for the L7 will be version 38. So when 39 is released, you wouldn't be able to take an L7 to firmware 39. So if today you're designing a brand new system on a 5570, you're building on a platform that's near the end of its runway. So this is not fear, this is just planning with life cycle right in front of you. So where does the L9 generally earn its place? One thing I always remind customers that bigger is not always better. The L9 is an outstanding controller, but like every controller in the Logix family, it was designed for a specific range of applications. Where it really earns its place is where control complexity is growing, high axis motion, large connected systems with lots of devices and data, modernizing projects where you can already see the next expansion is coming. And I'll be honest about where this is not the answer. A small, stable machine, no new demands, may not need this platform. Our job as engineers is not to recommend the biggest controller, it's to recommend the right one. A quick way to know if it fits: growth is already planned. The architecture is getting fragmented. Security expectations are rising, or modernization is on your roadmap. If 2 or 3 of these are true, the L9 is worth a closer look. And when it does fit, you're choosing from a whole family. Rockwell has built a complete family of controllers, from ControlLogix through ControlLogix, all the way up to the L9. So there's a solution for just about every application. The 5590 itself, there are versions for standard and safety, for harsh and corrosion environments, the XT version, and for process applications. Selection starts with the requirements, such as the environment that you're going to be put in. If it's a harsh environment, maybe you're on a boat or a ferry or some other harsh environment, you may want that XT version. It's not always the biggest memory size that's the right fit. Sometimes the harder part is not choosing the controller, it's convincing purchasing why you chose it. The family even includes a plant PAX process version, the PS option, with redundancy, support for high availability applications. And every one of those names is really a coded part number. Let me show you how to read it. So this is generally useful on a quote. Take the 1756 L980TS. The 1756 is the ControlLogix platform. The L means it's a Logix controller. The 9 is the family. So that's your 5590. A 5 would be a 5550, an 8 would be a 5580. The next two digits, 80 for example, are the memory in megabytes. So plenty of memory available for you to use. The T on twisted pair. The S means it's SIL 2 safety. And if you see XT on the end, that is the harsh corrosion resistant version. Blank means standard. Once you can read it, you can size the controller in your head and spot the differences between an L950 and an L980 on a quote with just a glance. Let's start with the headroom and capacity. One of the biggest enhancements is the increase in memory and overall application capacity. When people hear more memory, their first reaction is often, well, I don't use all the memory I have now, and that's a fair point. But memory is not just the size of your ladder program anymore. Think about everything the controller manages: more devices, add-on instructions, more diagnostics, more motion, and more data. Those all consume resources. On the screen, you could see numbers like up to 80 megabytes of memory, up to 512 motion axes. Please call me if you even get near that, which is double. All those features are double what the 5580, and you can connect over 600 Ethernet IP nodes. Machines almost never stay the same. Customers add another robot, another vision system, another line. Additional capacity gives you room to grow without immediately hitting that proverbial dead-end wall. I always tell customers it's much easier to leave yourself some room than to explain to your boss 6 months later why the controller needs to be replaced. I ask, how many of you had the customer ask for just one small change after the project was already done? A simple sizing rule: if you already know that expansion is coming, include it in your very first sizing conversation. It's far cheaper to plan for it now than to rework it later. But capacity is only half the story. Responsiveness is the other. When we hear the word performance, it's easy to think, okay, it's just a faster processor. Yes, it is faster. Versus the 5580, we're talking up to twice the scan performance and twice the motion axes. But that's only part of the story. Performance today is not just executing logic faster, it's handling larger applications, more devices, more motion, more data, all while keeping the system predictable and reliable. Years ago, the controller's main job was just running the machine. Today, it's talking to drives, HMI, vision systems, robots, historians, and plant-wide networks at the same time. Something I've learned is the bottlenecks move around. Years ago, it was the processor speed. Today, it might be networking. Tomorrow, it might be more data or motion. Having more resources across the board gives you flexibility as applications grow. Controller performance is not about bragging rights. It's about headroom for the next project. One thing all this capability depends on is connectivity. It's become recently a core requirement. So let's talk about it. Communications has changed dramatically. Years ago, connecting a controller to an HMI, maybe a couple of drives, was pretty much typical. Today, that's just the beginning. Modern machines connect to vision systems, robots, smart drives, I/O link devices, plant networks, historians, and sometimes even cloud applications. There's a tremendous amount of information moving across the network. The L9 was designed for that. You get two 1 gig Ethernet IP ports, keeps the controller at the center while connected design gets simpler. Sometimes customers tell me, we just want to add one more Ethernet device. Before you know it, one more becomes 10 or more. It's amazing how much connectivity has changed. Years ago, I only had to worry about the machine running. Now I also have to convince IT that I'm not trying to bring down the company network. Those two ports also give you topology options, a simple linear network, or DLR, a device level ring, that is resilient to a single breakpoint, chosen to fit the application, not the default. And increasingly, the network has to carry information out of the machine as well. The other half of the connectivity is getting information out of the machine and up to the systems that use it. The L9 supports open platform communications, unified architecture. I'm not really a big fan of acronyms, so I felt I should speak that one out. This is a secure standard that's a doorway to your data. But here's the mindset. I want to encourage the question is not that can I expose data? It is what data is actually useful? Who needs it? How do we protect it? Start there. Pick the data that helps operations, quality or maintenance. Bring in IT on the security side early. So one of the things, protecting the data leads us straight into the things that Rockwell built right into the platform: safety and security. Safety has become a part of almost every new machine we build. Years ago, it was not unusual to have a completely separate safety system. Today, we're seeing much tighter integration between standard control and safety while still maintaining the required safety integrity. The goal is not just more safety features, it's to simplify the system design, improve diagnostics, and make troubleshooting easier without compromising safety. When everything works together as one platform, it's much easier to understand what's happening on the machine and why. One practical note for when you migrate a project: if you open a ControlLogix project against an L9, safety comes in already enabled. If you open a standard ControlLogix project, it comes with safety off. You just have to check the box when you need it. So remember, every L9 is safety capable SIL 2 right out of the box. SIL 3 is achievable. You do have to add a safety partner. And if you don't want safety at all, you can simply uncheck the box. Now let's talk about a subject, whether or not we like it or not. Cybersecurity has become a part of every controls engineer's job. Years ago, most of us worried about getting the machine running. Today, we still have to get it running. We just have to do it securely. Manufacturing networks have changed. Machines that used to run independently are now connected to plant networks, business systems, remote support, and sometimes even cloud applications. Cybersecurity is no longer something we could just hand to IT, although sometimes it would, IT would probably prefer that we did. The good news is that Rockwell built a lot of these security features right into the platform. It aligns to the IEC standard and supports things like SIP security, secure boot, which makes it easier for controls and IT to work together instead of against each other. The takeaway is not memorizing standards. It is that the security was designed from the beginning instead of bolted on later. Good security and good support both start with the same thing: visibility at the machine. Here's something I've always appreciated: good diagnostics. When a machine stops, I do not want just to know that it stopped. I want to know why it stopped. The operator tells us the machine just stopped. The diagnostics tells us why. I'll take the diagnostics every time. The display and status indicators on the front of the controller, plus the QR code that leads straight to the manuals and support, means the technician can confirm the status, the network, the safe state at a glance. At startup, during troubleshooting, and during handoff, the visibility saves real time. On a tough call out, 2 in the morning, it's worth a lot. Nowhere does that matter more than in demanding motion application. The other area where the L9 really shines is motion. Whether you're designing a packaging equipment, material handling, robotics, or other high-performance machinery, motion keeps becoming a larger part of modern automation. Even if your current application does not need coordinated motion today, it's worth the understanding where things are headed. More servo axes, more robots, more synchronized control every year. Remember, the L9 roughly doubles the motion capability of the 5580, but the controller is only one part of motion design. Control network and operations all have to move together. It wasn't that long ago that adding one servo axis seemed like a big deal. Now it's not unusual to see machines with dozens of coordinated axes. All of this rides on modern tooling, so let's talk about the software for a minute. One practical planning note is that will save you a headache is the 5590 needs Studio 5000 Logix Designer version 38 or newer. So make sure you have those Tech Connect contracts in place so you can upgrade your software. Verify the exact version and firmware path before you start. Do not assume. A couple of things from the field. First, the 5590, you can now read diagnostics and web data right into your program. Second, and write this one down, the older PID instruction is replaced by PPID. So if you migrate a project that uses PIDE, it will fail verification and you will need to convert it to a PPID. Much better to know now than discover it during commission. A good migration is a hardware and software project, so design, validate, and deploy. Which finally brings us to the migration. The strength of the Logix platform has always been protecting your investment because Rockwell keeps building on the architecture. Your programming environment stays Studio 5000. Your engineering knowledge stays valuable, and much of your existing infrastructure carries forward. That said, the same I/O support does not make every migration automatic. A good migration inventories the existing system, plans the target architecture and a rollback, and proves it in a controlled setting before the changeover. If the plan does not include firmware, software, safety, networks, and testing, it's really not a plan. Customers, they typically don't like surprises. They want to know what changes, what stays the same, and what the path looks like. And honestly, I've never heard a customer call and say, Robert, I was really hoping this upgrade would be more complicated. Here's a simple tool to start that plan. If you take one slide home today, take this one. It's not a pass or fail test. It's a starting point, a checklist for any migration conversion. You have basically 6 areas: your application size and performance. Do you have a current baseline? Do you know the size of your current application? Motion and safety. What may be my validation impacts? Networks and connected devices. What changes in the topology or maybe even the access? Software and firmware. What's the approved compatibility path? Operational support. Who owns the documentation? Who backs it up? And what about training? And finally, your expansion plan. What is it likely to change? after you actually go live. You don't have to answer every question today. The value is knowing in which of these needs a deeper look. If you've got a project in mind, this is exactly the list Turtle can walk you through with your team. So we've covered a lot of ground. Before I give you the 3 big takeaways, if you have any questions, feel free to put them in the chat. So let's take a moment. Let's see here. A couple questions and should be ready concerning L9. So I don't know, at this point, I'm pretty much kind of finished up. But if you have any particular questions, I could take a look at the chat, or if somebody's got the chat, maybe Jen, you could read one of their, if there is any chat at this time, we could read them off and see if we could tackle them.
We did receive a question about PPID auto-tune functionality and when it'll be available. Anthony Vu, thank you very much for responding, saying it will be a version or available for version 39 of Studio 5000, which is tentatively scheduled to be released September 2026. Other than that, I think we're all set.
Thank you. So 3 things to take away. The first, the L9 is not just a faster controller. It's built for where automation is going, not where it's been. Second, the biggest improvement is not any single spec. It's the combination of performance, scalability, connectivity, integrated safety and security, and plenty of room to grow. The third, the most important one, the L9 is not meant to replace every controller. It's for applications that need the additional capacity that we talked about today. Our jobs as engineers is to recommend the right solution for the application, not simply the biggest controller in the catalog. Plan for headroom, unify with intent, and modernize deliberately. These 3 engineering habits pay off every time. Leave you room to grow, document the architecture, plan the handoff, testing, backups, and training, and of course, the ownership before startup, not after. So if that's all we have, anybody have any additional questions? If not, thank you for joining us, and please be sure to check out on YouTube our past Talk Tech with Turtle presentations. Thanks again, and hope to see you on the next Talk Tech with Turtle.
Thank you, Robert. Thank you for joining us for Talk Tech with Turtle every other Tuesday at 10 a.m. Sign up for our next session on Otto's autonomous mobile robots presented by automation specialist Kevin Vucinic.